speaker two. We have Dr. K.S. Musti. He is the Associate Professor in the Department of Electrical and Computer Engineering at Namibia University of Science and Technology. Dr. K.S. Musti received B.Tech in Electrical Engineering from sorry for the network connection. So again, I'm proceeding. Dr. K.S. Musti received B.Tech in Electrical Engineering from JNTU and 19 Academy with the Namibia University of Science and Technology as an associate professor in the Department of Electrical and Computer Engineering. He is involved with several projects in the areas of big data, enterprise information system, and demand-side management. He has more than 30 years of experience in industry,
Ms. Bhavika, can you hear me? I think there is some network issue at your end. Ms. Bhavika, can you hear me? Your voice is not audible.
Dr. Sastry has a significant interest in core and multidisciplinary research and published more than 50 plus research articles and book chapters in the extended areas of energy system, database and information systems, big data, and soft computing. He has won the IEEE Travel Award for My Paper to Go, Japan in IEEE Circuits and System in 2005. He has organized 4 short-term course program, STCP, faculty development program, several expert lectures, and has been invited as a key speaker, session chair in various workshops and conferences. Dr. Sastry has received various universities across the globe to serve in various capacities. He is a visiting professor with ESIG GELEC, Round Data Sciences, France, Sofia University, Japan, Data Science, University of Torabo, Puerto Rico, Energy Systems, and KL University, India. He is on the panel of accreditors of IEEE, EBIT, USA, and visited a few universities in the part of EBIT accreditation process. Dr. Sastry is a senior member of IEEE, USA, and a member of IET, UK, and a life member of IE, India. So I request sir to please present his views.
Yeah, Professor Musti sir, please share your screen.
Yes, a pleasant greetings, good morning, good afternoon, and good evening, and good night, from wherever you are. Here in Namibia, it is about 5 minutes to 4 o'clock in the morning. Kind of cool outside. We are just entering the winter season. I will try to present my screen. Let us entire screen share. Just let me know if the screen is visible.
Sure, sir. Sure, sir. Yeah, it is loading, sir. It's visible, sir. Visible, sir. Please proceed, sir.
Okay, it is visible. Is it okay?
Yes, sir. Perfect.
Okay. Okay. Today the lecture is on data visualizations. This is what is a trending topic right now in any field, we would like to take, my background is energy systems and power, which I will deal about 90% and 10% on a research project that I have done in the past on health informatics. I have done several projects, several consultancy works in data in different areas basically. I don't want to bore your audience. I would like to show some demonstrations wherever possible and all that. So this is basically the breakup of today's lecture. We will see data, information, knowledge cycle, what is basics basically, and then fundamentals of data visualizations, and then we focus on case studies. Power system or energy system, like ESI stands for electric. Probably we may have a feeling that without data visualization, informatics, you won't be able to do the demonstration on that for obvious reasons because of ethical issues and all that. And then in each example, what we do is that we do a and application of which is the topic of the lecture. So we start with the fundamentals. Basically, we all know that the data, we don't go into the details how the data is collected, how it is processed and all that, because this is a keynote. Now, the cycle of the data is that we actually data, when it is processed, it becomes information, and when we derive kind of some useful knowledge, we call that as a useful knowledge, though the cycle is showing these things.
Yeah, Musti sir, your voice is not audible. Musti sir, I think there is some network issue at your end. Sometimes
Really?
you, yeah, yes, sir, yes, sir. Your voice is not going properly, sir. Sometimes it is. Yeah, now it's perfect, sir. Now it's okay, sir. Please.
Where we can get the settings. But it should be working. Is it breaking up? Hello?
Yes, sir. Yes, sir. Yes, sir. Earlier it was breaking up, sir. Now it's okay, sir.
Okay, okay, okay. Let me try. Okay. Oh, sorry. Yeah. So our focus is we basically.
Again, sir. Again, sir. Voice is breaking, sir. Sir, your voice is not coming properly.
Oh, really?
Yes, sir. Yes. I don't know why it is happening. Maybe sir, some network issue.
Is it for everybody or I don't know?
No, sir. Only for you, sir. This time it is happening, sir.
Because I didn't actually hear my introduction also. Or otherwise, is it okay if we stop this? I don't know, because from my end, I have the 4G plus. I have no problem.
Now, sir, it's okay. Now this time it's okay, sir. Please.
Let us see. Okay, I'm sorry how it works and all that. Or otherwise, feel free to stop and I don't know what to do.
No, no, sir. Please proceed. We are
Yeah.
here to Listen, you sir.
Okay. So these are some of the things for obvious things. We don't have to really describe what is an infographic, what is a chart, what is a diagram, what is a map and all that. So we don't deal with basics. If you are a data scientist, yes, one needs to know about the fundamentals and all that. So this is another visual. If the visual is not clear, these are the things we use: computations, statistical distributions, and then we arrive at dynamic or static visualizations and all that. So these are my recent publications. Almost all publications, recent publications in 2020, last 5-6 years. Now, every every publication is directly related to intense data visualizations. We even used machine intelligence, artificial intelligence, machine learning, and at the end, the results need to be shown in data visualizations and all that. Today, more papers, more consultancy works, more activities are centered around the visualizations, because if you at the end you have a large data, how do we summarize the solution in one word? Is data visualization. That is the key. So what can be done with the data visualization? If the information is complex, we can understand easily. We have to make some decisions. Yes, we can make it easily with the visualizations. Effective communication, we can easily interact with each other, among the stakeholders, among the decision makers, among the participants, among the contributors. We can have effective kind of communication based on the trends and all that, identifying patterns and trends and all that. All these things we will display using some simple visualizations, MS Excel based and all that. Importance, why these are important? Anyone basically can understand the data and the patterns, the figures, and that is the importance and all that. So there are lots of visualizations are there. Basically, the first visualization that comes into the mind is the dashboard, which we will see some examples that we have done with our students here at NUST and on my own and all that. A lot of research we have done. All our work is centered around data visualizations and all that. Some reports, animated charts, infographics, everything we have in this lecture and all that. Now, once again, we actually go from the data to information, knowledge, and the wisdom. I won't be able to display everything, like we can't demonstrate up to wisdom and all that, but definitely we will be able to get up to information and knowledge and all that. Okay. First of all, we go to data visualization. This is the first kind of a example case study. ESI stands for Electricity Supply Industry. On the left, you see a kind of infographic, which is to explain the problem. Basically, in any country, most countries, let us take India. Peru may not be the good example. I'm not sure about, because I am not sure about Peru. But in India, some energy is imported. I don't know how many of you know. Nepal and Bhutan both export to India. And of course, within India, they have state-owned generations, government-owned generations, and then energy from IPPs, independent power producers like private investors, privately owned, Adani, Tata Power, CESC, solar power plants to different coal power plants and solar power plants are the examples. But typically, private investment is not allowed in projects like hydropower and all that. That's a separate discussion and all that. Then all the energies, all these three energies, basically they have lots of constraints and all that. They have their own issues. They feed into consumer demand at the end and all that. But the consumers, they may not be having all the awareness required. The demand only is going up and all that. Now, how do you do at the national level? That is the question. So how this business happens quickly, I have just explained the coal power plant, then wind power plant and solar power plant, something, something. These are the customers here. This is the solar power plant. Basically, most people do not understand what is a virtual power plant. Yes, virtual power plant is a physical location. It's a huge facility, basically, where power is purchased from different sources. Yes, power is purchased from different sources at different costs during different times of the day, different seasons over the year, continuously, and then through the power plant they supply through the substations to consumers and all that, like this. Now, energy production happens in different plants located in different locations. Load varies continuously. Generation and load must be balanced. You know that if the generation is too less, you can supply to the customers. If the load is kind of too low, the generation will be, there is generation, but people cannot use it. That's a waste of generation. That means planning is not proper. So what is the relation with the topic of discussion? If you look at this visual data visualization, there are some solutions, but they are at the startup levels. That is why it is a keynote lecture. This is a startup business right now. Virtual power plants, providing software to virtual power plants is considered as a kind of startup business right now and all that. So what kind of activities we need to do, what kind of visualizations we need to do and all that, let us look at it. Let us understand load side, because we talk of load, and generation side and all that. So on the load side, I don't want to bore with, but there should be some kind of understanding. We need to understand some load, peak load, load factor, demand factor, blah, blah, blah. And importantly, we need to display the load using load curve or load duration curve. That is the point. So how the load curve looks like? This is the first visual in the lecture. Please understand, we are dealing with the energy system, and on the load side, this is the first visual. This is a simple plot here. Right now, it is a simple plot. We have several examples basically to deal with. So we start with simple example and all that. What you see is a load over the day. This is midnight and going up to the day, through the day. This is midday, mid-noon, and then evening. And this is simple. The load is the actually shown. Time of the day is shown on the x-axis. It is shown on the y-axis. So as the day progresses, load increases. In the mid-noon, the load is high. This load curve is only for example, but this should be drawn as per the data. So this is only an example and all that. Okay, sir, this is fine. But what is this on the right-hand side? Okay, please listen carefully. These two are actually same. Yes, I repeat, these two are actually same. If you see 350, this is also peaking at 350. And what these visuals? That is the magic in the kind of requirement, user side requirement. One is called daily load curve, another is called load duration curve. Now, the questions normally, okay, you have the load, but the power plant, virtual power plant will ask, okay, the load is moving like this, nice. How much power and for how many hours I need to supply? Because this is the load, we need to supply this load. How much power for how many hours I need to supply? So to answer these questions, we need to draw load duration plot. Basically, let us say you take this piece, the peak. The peak is existing around 2.5 hours. Look at this. That means, please listen once again, this peak is existing for 2.5 hours. And it is shown here if one has to look at this visual. It is not clear, and this visual explains nicely. 350 megawatts or kilowatts, whatever it is, it should be supplied for 2.5 hours. Now that answers this question. Fine. Now the issue is that you need to find somebody who can sell, who has the capacity to sell 350 megawatts of power over 2.5 hours. That is the key. And then definitely we have a base load here. You need somebody that can supply like 70 kilowatts, like 70 kind of megawatts throughout the day. Now, who will supply this? That is the question. Throughout the day, a minimum of this much load is there, so this needs to be supplied. Please understand, if you buy from solar plant is not available all through the day. It is available only through 5 hours or 6 hours in a day. So this requirement of 70 kilowatts or whatever cannot be supplied by a solar power plant in the night time. So these are the zones. This is the first example of visualization. Who decides on the above? And there are many generation plants, there are many solar power plants, there are many coal plants. How do we decide? Let us say a country like India, so many states, let us say there is a requirement in Maharashtra. Do you buy power from a solar power plant that is there in located in Uttarakhand or Delhi? Based on what you will decide that? That is the question. So let us see how it actually goes ahead and all that. Now we have seen the load side. We understood something. These are the visualizations. But I would like to tell you there are other different types of visualizations on the load side. I'm just giving a kind of example here. Now the other side, the generation side. Now look at this. The solar is probably from 5 o'clock in a country like Namibia and all that. Very the sun is kind of, the sun has blessed this country nicely. So we have more hours here, but after 7 o'clock in the evening, the plant will be kind of, any solar power plant will not be able to. Basically, this visual represents a typical power production from a solar power plant. There may be some 10 power plants in Namibia. We have about 25 power plants in India. You should know, the Indian participants should know that the world's largest solar power plants are actually located, 2 or 3, even more are located, top 10 are located in India. There are different types of solar power plants are there, on the water, on the ground, etc. and all that. Details can be seen. So each power plant will have a visualization like this. And now if you talk of wind, it can be like this. Wind will be low when the sun is shining, and normally it will be more when during the night and all that, but it can be very random. So therefore this is one of the visualizations I just have drawn for example. Now we have seen both sides. There are many power producing plants, coal, solar, wind and all that. Each has its own costs. There are different ways to put the costs and all that. Can we buy more solar power plants? This is the question. Everybody. People think that we can buy solar power because it is cheap. Yes, it is cheap. And it is renewable. It is green. Very much green. It does not pollute. Can we buy more? And what this question has to do with the visualization, that is very important question for this lecture. Now there is an issue with solar power, what we call duck curve. I have researched on this and this is my publication. What is a duck curve? Duck curve is, duck, it is a kind of bird that doesn't fly much, but when you see the duck on the screen, on the computer screen, then there is a challenge. Let us look at this one. It is first identified in America, in California in 2016. You see the graph here. It is looking like a duck actually sitting. And when you see this in the visual, then there is a problem. What is the problem? The duck curve simply indicates, I don't want to read through the slide. I just would like to explain. A ducker, when you hit, when your graphs are showing a duck or something like duck, close to duck, that means solar generation is excess, very high when compared to the load, and there is no load really, but generation is more, and you don't get paid for the energy that you produce, which means somebody has to shut off, close the power plant. Let us say you have 100 power plants. Some power plants must be closed because there is a duck on the computer. And the computer means basically duck pattern will result when generation is excess, especially solar generation is excess than the load. Will it happen in India? Yes, it happened. I don't want to bring the references and all that in other lectures and all that. Normally, when the government asks for solar energy, then when they float the tenders, there will not be any bidders anymore, because the graphs, the analysis, the risk analysis would have shown the duck. Probably there may not be enough margin, or in just a few megawatts of energy production, the situation may kind of result in duck curve and all that. So this is one of the visualizations and all that. Those who are interested, they can read. This is how it looks. There is a lot of literature. My paper is one of the popular papers where we discussed. So there are several examples of utilities facing duck curve, or well documented even in India, America, and all that. So that is what we did. The analysis, if you use analysis, any tool and all that, we used some of the tools, because when you are dealing with visualizations, you need a lot of tools and all that. In this case, IrenaFlex and SAM, we have used. Both are American softwares. Both are free, but there are other authors, they have used other expensive softwares and all that, but it is up to one's wish and all that. I don't want to go through the mathematics and all that, but a lot of math is there behind producing your visuals and all that. That is the case scenarios you have to consider. If you kind of go through these case scenarios, tables and all that, this can be boring, but one can understand there is option of coal, oil, hydro, PV, blah, 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 and all that. But which one, how they look like in each scenario, how they look like, the visualization is the answer. So even here you can see a small duck here, that may be possible and all that, but once you understand the visual and all that, you can, if the duck curve is nearing, then you don't invest into that market as an investor. Let us say you have money and you have intention to invest in one of the, so you want to build a solar power plant and make money. If the market is approaching, which means if there are other players are already there and duck curve is happening, then there is a risk. The visualization, data visualization exactly helps in providing the margin, and thus one can calculate, estimate the risk and all that. So we have looked at data visualizations of load generation. We also understood duck curve and all that. Okay, fine, making some sense. Then how do you manage the system in real time? So you have so many energies and all that. So how do we manage in real time systems? Before that, I would like to show a kind of demonstration, basically, to make some sense and all that. So let me take the demonstration here. So this is basically what you are seeing is the live demo of the simulation that we developed. This is the base plot of what we have seen so far. You can delete it. Basically, this represents a kind of load, not the generation, a load. And if you have to do this, you need to do some calculations to put it into load duration. Load duration is very important, very, very important for virtual power plants. From this, you can understand how much power and how long that power should be used and all that. So this is what basically the demonstration, the same thing. I want you to understand and appreciate the visualization. Same thing you represent in different way, not just for plotting something or some color graph and all that, but to provide a concise information for the user requirement. The virtual power plant basically requires this one and also this one. They must have the visuals, both the things and all that. Now let us look at the kind of energy kind of the generation side and all that. Sorry, just zooming it. And okay, let me manually delete these guys. And so basically, if you want to add coal generation, the beauty of coal generation is a base load. I don't want to go into the details, but coal has the capacity 24/7 because you are burning the coal, so it will produce, it can produce a constant power throughout the day without any issue because we are burning the coal. I want you to understand different things here. Coal has its own cost, its own environmental issues. That is okay, but we want the visualization here. The visualization looks like this and all that. And then the solar, okay, the visualization, I have done the visualization in kind of in a way that anybody can simulate nicely. And we can change it. And now it looks like this: 8 o'clock to 7 o'clock, 8 o'clock to 5 o'clock, sorry. And all these parameters can be adjusted. I don't want to go into the details. Now see the difference between the visualizations. A coal plant looks like this and a solar power plant looks like this. Obviously, during only few hours it is there. When you mix it, because you are buying from different guys, how it looks like. It is very simple, of course. Now you have, these are simple mathematics, simple plot, but with the big data on a scale of India, you don't have to talk about on a scale of India. Even a small state, you take any state and all that, there will be a lot of data. It is only big data, and you have to have the summation every 5 minutes or every 15 minutes or every 30 minutes. And basically in India, the standard is every 5 minutes. That is the billing cycle. So you have to get these. So now the energy mix looks like this. This is here taken on a kind of simulated case, but the real data will not be like nice and smooth like this and all that. So let's go back to the lecture. So that is the demonstration, first demonstration we have done. Now, how do we manage the system in real time? So you have the load, you have the generation, everything is changing constantly. We have published a white paper. This is the consultancy work that in Trinidad and Tobago that I have done. Full PDF is there and all that. What you see here is a 3D visualization. This is very, very important. I will quickly explain. I don't want to go into the details. So on this here, you have the locations. Scarborough, these are the Point Lisa, Sco, Pinal, Debe. So these are the locations. Here we have the load actually represented. You may ask why these are so many kind of the 3D and all that. The loads here, this represents in a particular half an hour. Next half an hour is this, like that, like that. This is the past data. And this, the brown color, is the present data, now happening. So this entire visual moves from left, right to left. It continuously moves, and this is the real-time data, the orange color and all that. And this one is very important, forecasted data. So therefore, this is the measured data, past data, and this is the measured currently happening, and this is the future predicted data. Why this is important? Based on this data, if you want to adjust your power output and all that, you can adjust and all that. You can see how the blocks are actually moving and all that. And mind you, this is written in a very complex way. We have done at our best and all that, because this is a field work. This and this are same. Actually, this is rotatable, and this is how it looks. You can actually click on particular thing and all that. You can see the details and all that. So this is the kind of zoomed version here, and POS is Port of Spain and all that. Now this is how it looks. You can actually rotate this as you want, and if you want a plane graph also, you can see the plane graph and all that. This is the real-time data and all that. This is how we manage. The control part I don't want to deal with here, because we are looking at only data visualization, which is actually more okay. Now, okay sir, it is making some sense, but of a nation, now we want to see how this sector is managed at the national level. Now, how do we manage this and all that? Before that, before we understand at the national level, of course, I have a visual, I have a kind of demonstration also for this. We need to understand supply industry is decentralized and regulated. Any country, India or anywhere within the state, also it is decentralized and regulated and all that. And which means the generation companies are called Gencos, transmission companies are called Transcos, who transmit power. They buy from generation companies and they transmit, they sell to distribution companies and discoms and all that. So it is important to visualize both generation and load in each region over the years. That is what the kind of thing and all that. So basically we understood something, we can do the visualizations and all that. Now I made a tool for this. It is published and it is available on Elsevier data, open data and all that. Let us look at how it looks like and all that. Now, this is what you are looking at, and this is the visualization. Many people have used, and these are two research papers that I could quickly put together on this data. So what you are seeing is the load research analysis dashboard. Basically, you have the years here. I will show the demo also. And actually, we have an improved version right now and all that. And this is the old version that what we see here. And we see the domestic load, commercial loads, industrial loads, percentages. These are all visualizations. So you can see the breakup here quickly, and you can see the months, and you can see the generation here, total energy production, whatnot, and all that, cities break, everything you can see. And we have done a kind of solar smart bench. Of course, I don't want to discuss much and all that, but technically you have lots of sensors in the solar smart bench and all that. There also you have the same type of visualizations and all that. This is the dashboard you see. And this is also dashboard. You can click on the year, you can click on the region, you can click everything and all that, which I will do a demo a little later and all that. This is the zoom kind of zoom in version. You can do weekday visuals, you can do weekend visuals and all that. And the demand pattern is also indicated over the months and all that. We used a lot of data for this. Over 8 years of data we have used, and we have developed this tool and all that. Here in Namibia, you can see the regions, you can see the towns and all that. It is available for open use in the public domain. Now, for the national level, we have this kind of research tool. This is an example. This is the recent one. Why I am talking a particular pattern? You see, all these things, these are different visuals. These are bar charts, line charts, whatnot, and all that. One particular thing that a type of visualization I want to bring is very important, which is called SANKEY, which is very important in energy engineering and cash flows in different fields. For example, we have done a banking example. It is published in Emerald Journal, and now we are doing extension work on this and all that. So if you see on the left hand side, different regions, the energy is flowing and energy is produced and energy is kind of consumed, and that's how it is flowing left, right, and center and all that. From Sankey, you can make out a lot of things and all that. So, okay, we understood some adjustments can be done on generation side, but because you can adjust your coal, well, not quite. You can't adjust the coal generation quickly. It is something like an elephant sliding down. Example is the example elephant sliding down the hill. You can't control it. It is a huge animal and it is coming down a ramp, a slope. So the elephant is an intelligent animal. Power plants are also very smart, of course, but there is a limit on the elephant because of its own weight. So it will try to protect itself, and it will do different things in coming down the hill and all that. Same thing with coal. For example, in simple terms, what happens if you want to adjust coal output and all that? If you want to stop, it takes about 12 hours to cool down because it is a lot of coal, it is heated and all that. It takes 12 hours to cool down. And let us say you cool down and suddenly you want the load is going up, and suddenly you want the plant to come up. No, the plant will not come up from 0 degrees to 500 degrees or 800 degrees centigrade and all that. It normally typically takes 16 hours to start back up and kind of come back and all that. So therefore, coal power plants are not controlled. They're controlled, fine tuning only is done. They're not stopped and kind of started quickly and all that because of the issues of inertia, ramp up and ramp down issues. So what we do is that we stop the solar power plants, which are kind of more green, but that is the reality and all that. So how do we we do adjustments on load side? How do we ask customers to reduce or increase load? It is very interesting. We use demand side management for that. Demand side management is a completely visualization, data visualization. So it is basically we influence customers in kind of consumption patterns and all that. Say for example, you rise the petrol cost in any country by $5 or 5 rupees or 5 pesos or whatever. What happens? People will start initially consuming less because it is expensive. People cannot afford. So by adjusting the tariff, the power system is a very nice thing and all that. We do the same thing, but for that we need the patterns and all that. The theoretical approach is, if you see, this is the theoretical definition. There are 6 methods. If people are consuming more, we apply more tariff here so that they will not consume more here. And here people are not consuming, we increase the price here. We increase the price here so that, here also people consume more. And here, sometimes we ask the customers, oh, you're consuming here, please go here. So there are different ways we can do these things and all that. And let me show some kind of, this is a strategic conservation, strategic load growth, flexible load shapes. So many are there and all that. So I published the enterprise information system for demand side management. Basically, it is an electrical engineering problem, but 90% is computer engineering side and all that. It is very complex. I don't want to bore you with the complexities and all that. But if you see, demand side management is more about big data visualization and computation of financial technical parameters and all that. And there is a custom JS and all that. Now, let us look at the demo of this. Can I do this? Yes. Now, this is what one of the things that we have seen 6 methods. One of the things that we do here, quickly, let me show the demonstration. So here we get back to the original peak shaving. We do certain studies. Basically, if the load is more here, more people are consuming, we apply what is called peak shave. Peak shave is like this. Now, peak shave is something basically you apply some high tariff, people will go down and all that. You can simulate these things. If you subtract 100, in this case it is 100. Let me zoom up a little more. 100, this is the thing and all that. And basically you go back, and if you do 200, and peak shave, it is more now and all that. You can do these things. Why these things are important? You can determine how much shaving is possible and all that. This is the actual thing. This is how it goes on, but it is practically impossible to subtract 200. This visual is drawn after subtracting 200 from every kind of point, assuming that there is a reduction of 200 kilowatts or megawatts or whatever, if the price is made more and all that. That is what. Now the textbooks will not show like this. The textbooks will show like this, a nice clean shave, what we call peak shaving, but that is not practically possible, not practically possible at all, because you don't get smooth curves like that, but textbooks represent like that and all. So this is one of the visualizations. There is no software right now. This is the only software that we are using right now, but I still need to publish and all that. Now, if you apply solar thermal, most people ask, how do we simulate people, the demand side management and all that? We ask people basically to, okay, your bill is high, please put solar water heaters. In that case, let us say 80% of the people, let us say 80% of the people install solar water heaters. How my simulation, how that scenario looks like, that is where you need visualization. So we this is solar PV. If a customer adds solar PV, what happens in that case? There is a small solar PV generation at the customer premises, and the net load, they don't consume more load because they have their own generation. The net consumption reduces. Look at this. This is the small generation, this is the load, and this is the small generation, the customer rooftop solar and all that. Now the customer added, in addition to that, solar water heater. Solar plant is there, and the customer also added solar water heater. Solar water heater, what happens is that people use in the daytime and the evening. When they use solar water heater, basically they are not using electricity. That means electricity consumption goes down. So how do we simulate? Look at this. Small consumption is avoided from the electricity. Now more cut is happening and all that. So the green ones on the other side is due to solar water heaters, and during the midday the customer has a solar power PV production. So essentially the load consumption is reduced. These are all visual intense simulations. That is the point here. That is the point of the lecture. So this is the demand side management lecture and all that. So, okay, now these are all fine. Now let us go through infographics. So far we have done kind of computation related visualizations. Now let us say static and dynamic. They are equally important. They have a lot of business value. And what kind of data, data we need, and let us say you take a new energy system. Do you believe that data and infographics are really important? Yes, they're important. Let us quickly go through a topic which normally you don't hear, but it is gaining prominence. So we introduce what is called solar DHS, and then kind of show it with visuals and all that. So modeling and simulation of solar district heating systems. This is our master's work and all that. And what is basically solar district heating? District heating is that basically you heat the water at a particular what is called heating plant, and then you supply the water. Water just goes and comes back. Those who ever want to use water, hot water, they want to take a shower, they want to cook, they want to heat the space, no problem, they can use and all that. But the water will be used, some water is removed and it will come back and all that. So this is water district heating. So if you see the water, these all the design itself is infographics. This is how it is represented. So hot water is a commodity. So it is supplied through the red lines. Red lines means the hot water is carried to the customer. These are all customers. And the green lines represent the water that is coming back, the cold water. Cold water means the hot water goes as a commodity. The heat is removed. Some people take bath. Water is also removed. They pay for it, of course. There will be mechanism. In some states and all that, you have the prepaid water meters and all that. So water is metered and all that. So hot water is a commodity. This is how you represent. This is the infographics. Without these infographics and all that, it is not possible. How the infographics look like in this section? Basically, these are applications. and about 14% is used for 15% water heating. Space heating is 63. Actually, we use more thermal energy and all that for cooling or heating and all that. So this is one of the visuals. Look at this. I just want to introduce the concept. So this is how you need to demonstrate using the visual, because it is a new area and all that. So this is the infographic and all that. So you have your supply lines and all that. This is another visual here, displaying the same thing. But DHS, practical DHS, is actually happened in South Africa when I joined. In WITS, WITS was around university. It is one of the leading universities in South Africa. It is world ranking university, number 2 in South African system. They have, don't think that these are solar PV panels. No, these are DHS panels. These are solar radiation collectors. Very interesting. They heat water which is located in the ground stair and so on. That it is very interesting. So hot water is circulated, and this is how it looks. Solar energy is collected and all that. So what the visualizations have to do in this is a kind of interesting story. These are solar collectors, actual photos you can find on the YouTube and all that. I was one of the few who were invited to the inauguration and all that. It is captured in YouTube. You can see me on YouTube. If you go to DHS WITS Johannesburg, there is a video and you can see me also. Now, this is what the simulation looks like. So the water, hot water is there and it is simulated. We need to do a lot of calculations and all that. So there is no software for that. The only software that right now we have Australian software, where one of our professors who worked with this company for 30 years. So he's our colleague, he's our ex-dean and all that. So we are able to do this simulation, which means to do simulations and infographics in certain areas, you need powerful softwares or develop your own softwares. That is right now we want to develop our own software for this solar DHS. So here you see the space heater for cleaning, and you see the small water tap where people may take shower and remove the commodity and all that. These are all pipes and all that, and you see the calculations and all that. This is how it should be represented in a visual, not numbers, not plots. Look at this. The numbers are there, of course, but there is no, the commodity is represented here in a different way. But this is for an apartment complex. We have done the simulation using Flownex software. And here you see the temperature zones are represented with colors. And now coming to the point, colors are important, shapes are important. This is all about data science and all that. The software has a capability of actually displaying the colors based on the temperature calculated and all that. So that is what the visualization purpose and all that. So at the end, we show the DHS supply and all that with the different temperature zones for different customers and all that. Now let us go to other one quickly. This is very interesting. E-mapping we have done in Bhutan, we have done in Trinidad, we have done in Namibia and all that. Without this, the discussion is not complete. And let us look at, this is the map of Phun Shaloing town, Bhutan. Sorry for my pronunciation, if I pronounce wrongly. And this is the kind of old type visualization. This is done using AutoCAD. Those who are familiar with AutoCAD, they will agree immediately. So it is not just the recent computing power and all the tools. I'm not going into the details of tools where I specialize, where much of the specialization comes and all that. For example, IBM tools are there, Microsoft tools are there, Oracle tools are there and all that. I don't want to go into that. I want to focus on application. Those who are interested, they can talk to me later separately. Even they can do research with me. I have no problem. So this is the one. How do we visualize this and all that? We have actually done an energy audit. It is published in IEEE. Roshan was the former head of the department. He is my student in Bhutan and all that. Now, how the project looks like on the screen. Now we are showing, this is not a Bhutanese example. This is now the example in Trinidad and Tobago. This is also published, and this is the publication. Now let us look at the visuals and all that. So this is the Google map you are seeing on the left, but our GIS in our application actually has layers. This is how the real visualization kind of at the end gets and all that. On the right side, you see the visualization on the Google Maps, but this Google Map actually, whatever you see, the photo, the buildings, these things are basically coming out of different layers and all that. Let me show the layers also, how our software look like. Look at this. This is the map of, there are 3 layers here. Please look at the map. This is the Google map, the bottom layer. The middle layer is actually capturing what we call, we decolor it and we get the vector graph, basically vector graph. On top of that, we put only points. What are these points? These points are typically, in simple matter, these are the electric poles in the country. Electric poles and utility assets, and you have a substation, there is a point, you have a pole, you have a point, you have a transformer, you have a point, like that. So we plotted the points in one layer, and the vector graph without anything and all that, what we call the transparent vector graph, is in the second layer. The bottom layer is basically the actual map, the combination of everything and all that. Now how this looks on the screen, now this is how it looks on the, when you open our software, the Google map will be there, and some objects will be shown like this, and you also have the kind of menu items and all that, whatever you want select and all that you can select. But where is the network? Now this is the network. Look at the beauty. So our software actually displays these things. This is the visualization. Basically what you are looking is at the assets. There is a image. This visualization is a hybrid visualization where if you click interactive, you see the actual photo of the substation, and you have the voltage. You click, you get the details and all that. I don't want to go into the complete details and all that. This is published, you can do it easily. Everything is described in the paper and all that. It is a old paper. So, but gem of a paper. Right now, you may ask, sir, what is there in the research? Yes, there is a lot of research. The Google Maps, you cannot program anymore unless you pay. If you pay a lot of money, yes, you can program. But so Google kind of the platform is not available at free of cost. So this gives opportunity for the researchers to develop their own platform or use other open source platforms and all that. So there is a technology level contribution gap is there because Google has changed its payment things. And I must tell you, if you have interest in this, and please contact me, we can do work together on this and all that. Now we go on to the next topic. It is kind of, it is too much of electricity sector. Let us go into the health science. Health sciences. Quickly, I'm not going to take your a lot of time. What I have is a very limited information. I did publish a paper in this in the year 2012 or around. On we have done a control on type 2 diabetes, LQR method and all that. I don't want to go into the details. I just want to give you some kind of open information, thematic information. Not out of my, I'm very active in this, very active. I have a lot of experience with the data. I have a lot of data actually and all that, but due to certain issues and all that, we can't really present because it is real data and all that. Now, most of the people may not know that there are 3 types of diabetes. Type 1 people know, type 2 people also know. Type 2 is the common, what we call insulin resistance type and all that. There is one thing called type 1.5, what we call latent autoimmune diabetes in adults and all that. So this is one of the disorder, and it happens only in the adults. And so what? How this discussion is related to data visualizations? Yes, there is a lot. If you ask me questions, I will go on, but I will explain in simple terms and all that. There are lots of things. I want to put small things only here and all that. So first of all, there is a dawn effect, and also there is a Simogi effect. So it's very interesting. In the morning, the blood sugar shoots up, as you see. cortisol growth hormone actually starts to grow from 4 to the steep rise up to 12, and after that it takes down and all that. So dawn phenomena is something the liver dumps, the liver, human liver dumps a lot of sugar into the system. So people don't know that actually dawn phenomena is active in them, and that is causing the rise in the blood sugar and all that. So we need this visual for every human being. It is measured typically in kind of milligrams per deciliters. That is the kind of thing. And Simogi effect actually occurs again at the same time. It occurs. It happens if the blood sugar is very low or it is very high. Look at this. This is the growth hormone, cortisol, basically, or stress hormone, and this is what we call hypoglycemia, low blood pressure, and all that. These things have to be plotted for each individual. These things change every day. You change your diet, it changes. You do exercise, it changes. Diet and exercise. And you reduce your fat. Well, fat reduction doesn't happen over the night in 1 hour or something. Diet happens instantly. So you can see that. And you sleep less, it changes. You sleep more, it changes. So is a lot of factors that actually happen and all that. Now let me tell you how important it is. People think doing exercise actually controls the blood sugar. Yes, it controls the blood sugar. In some cases, actually, I shall tell you, if you are in the pre-diabetic region, which is the kind of most important region in the human life and all that, if you are in the pre-diabetic kind of region or progressing to type 2 diabetes and all that, these visualizations are very important and all that. If you exercise in a brisk manner, that blood sugar actually goes up, it does not reduce. I repeat, the blood sugar actually goes up if you do certain exercises and all that. So these are kind of dawn and Simogi effect and all that. And diet and exercise are not always the solutions. I told you sometimes it depends upon the diet is really measured typically in glycemic index. And again, for glycemic index, there are charts are there. These are very, very essential. The patients should understand basically the subjects. We don't call patients, we call typically subjects. So they need to understand a lot of visualizations and all that, or the consultant, the health consultant should actually assist you using those things. The data is collected in different ways. When the smartwatches will provide certain amount of data, for example, sleep, for example, how actually sensor augmented therapy and closed loop therapy, there are different things and all that. Sleep, during the sleep for adults with type 1 diabetes and all that. So diet and exercise are not always the solution. Sleep also affects and all that. Now this is what I am talking, strategies to keep blood glucose from rising during workouts. If you work out, some people may think, sir, the blood pressure is actually going up. The blood sugar, sorry, blood glucose is blood pressure is different subject, which I am not doing right now. Only blood glucose we are discussing here. You need a lot of visualizations to help and all that. No, sir, it's all okay. These are graphs and all that. What actually you mean to metrics? Everything. For example, diet, you have a metric visualization. We have seen sleep. Yes, there is a visualization. Those who have smartwatches, I don't have to tell. You may have already seen the metrics and all that. And the other metrics, for example, dawn and Simogi effects, also need to be taken into. If you combine all these things, I am leaving that as an open-ended question. How do you represent for a patient and all that? Now I am bringing a question. What you do with these? Okay, you do all the visualizations. What you do with this visualization? How do you advise? Let us bring that question. These are what is called training load. The training load actually peaks and then reduces, and there is a lot of information that you can infer, but the data must be there and all that. Now, let us say a person who is type 2 diabetic is getting ready for doing his workout for the day immediately now. But the person wants to know what type of exercise needs to be done, what should be the intensity, and how long that type of exercise should be done and all that. But these are obvious questions which have been resolved, but the software is not completely out. But you can figure out if you use lots of graphs, if you use sensors. Yes, you can, at the end you can get those things worked out and all that. I don't want to bore you. If you are using Garmin or Apple or Samsung Fitness, you have lots of graphs and all that. But I challenge, or I encourage, I don't want to use the word challenge, I want to encourage the researchers. How do you answer this type of questions? Let me ask another question. Okay, I'm doing 5 days exercise. There are two types of exercises. Basically, there are many thousands of exercises are there. Two types. One is a resistance type, body weight resistance type workouts, using your own body weights without using the any equipment and all that. Just use basically push-ups, lunges, or gorilla walk, whatever, and all that, pull-ups and all that. And then you have aerobic, anaerobic exercises and all that. So which one you should use, for how long? Can I do two kind of 2 days resistance type and 3 days aerobic, 1 day anaerobic? What type of combination we really need to suggest for a person and all that? So health informatics is, a lot of papers are written and all that. So I am keeping this as an open-ended question for you. So with this, my lecture, keynote lecture, comes to an end. Hope it is interesting. So we stop it here, and I would like the audience to basically throw questions and all that, and let me try answering them. Over to you.
Thank you so much, sir. It was a great presentation.